Hello viewers, Houndawg here again, flying with you in another famous aircraft from the past 100 years of U.S. Navy carrier aviation. Today is May 21st, 1945, and we are flying in the Grumman F8F Bearcat on board the USS Yorktown CV-10.
Radio check. 1, 2, 3, 3, 2, 1. Radio check. After the attack on Pearl Harbor, the U.S. Navy worked closely with Grumman to develop a fighter capable of dominating the Mitsubishi A6M0 in aerial combat. Grumman responded with the F6F Hellcat that entered the war in February 1943, replacing the F4F Wildcat. Although the Hellcat was a major improvement over the Wildcat, Navy veteran combat pilots still wanted more speed, maneuverability, and especially climb rate. Grumman had been intensively analyzing carrier warfare and in late 1943 set about to design the new F8F Bearcat to be faster, more maneuverable, and with a higher rate of climb than the newly operational Hellcat. The new fighter would also need to operate from smaller escort carriers that had been off limits for the larger Hellcat. The Grumman engineers realized that the only way to achieve all of these goals was to produce a smaller and lighter aircraft while keeping the same powerful Pratt & Whitney R2800 double WASP 2-row 18-cylinder air-cooled radial engine used by the Hellcat. The Bearcat's fuselage was 28 feet 3 inches long, almost 5 feet shorter than the Hellcat, and the wingspan was almost 36 feet. Both the wing and vertical stabilizer was the same basic size compared to the Hellcats, but much thinner. Structurally, the fuselage used flush riveting as well as spot welding with a thicker gauge aluminum alloy skin suitable for carrier landings. The Bearcat had a cramped cockpit enclosed by the first bubble canopy in an operational U.S. Navy fighter. It had self-sealing fuel tanks and armor protection for the pilot, engine, and oil cooler. The 12-foot 7-inch diameter Aero Products 4-bladed propeller was kept clear of the deck with longer landing gear, which combined with the shorter fuselage gave the Bearcat a significant nose-up profile on land. The hydraulically operated undercarriage used an articulated trunnion which extended the length of the oleo legs when lowered. As the undercarriage retracted, the legs were shortened, enabling them to fit into the wheel well, which was entirely in the wing. An additional benefit of the inward retracting units was a wide track which helped counter propeller torque on takeoff and gave the F8F good ground and carrier deck handling. The Bearcat's designers set a weight limit goal of 8,750 pounds, a full ton less than the Hellcat, but this was quickly challenged by the need for a stronger structure for aircraft carrier landings. The required weight savings was ultimately achieved by restricting the internal fuel capacity to 160 gallons and by limiting the fixed armament to 4 50 caliber machine guns versus the Hellcat's 6. Longer patrol flights required the Bearcat to sacrifice available bomb and rocket loads for one 150-gallon centerline mounted and two 100-gallon wing-mounted drop fuel tanks. Another 230-pound weight savings was initially achieved by moving the wing folding hinge system from the typical inner wing route to a point 2/3 distance to the outer wing tips. Only the inner portion of the wing was designed for full G-loads, while the lighter outer portions were designed to snap off when exceeding 7.5 Gs, leaving the aircraft still flyable. This system would prove to be too dangerous and unpredictable in normal operations, and the hinge points were eventually reinforced, requiring the Navy to place a maximum 7.5 G limit on the aircraft. In the end, the Bearcat was 20% lighter, had a 30% better rate of climb, and was 50 miles per hour faster than the Hellcat. The final design was completed in November 1943, and an order for two F8F Bearcat prototypes was placed on 27 November 1943, with the first prototype flight on 21 August 1944, only 9 months after the design effort started. The initial test flight demonstrated a 4,800 foot per minute climb rate and a top speed of 424 miles per hour. Flight testing also confirmed a number of problems, including a lack of horizontal stability, an underpowered trim system, landing gear that could only be extended at slow speeds, an unreliable airspeed indicator, and a very cramped cockpit. The test pilots also requested that 6 guns be installed. The stability problem was addressed on the second prototype by adding a triangular fillet to the front of the vertical stabilizer. The extra guns could not be incorporated due to weight and balance considerations. The Navy placed a production contract for 2,023 aircraft on 6 October 1944. And on 5 February 1945, they awarded another contract for 1,876 aircraft from General Motors with the designation F3M-1. Deliveries from Grumman began on 21 May 1945. The end of the war on August 15, 1945, led to the Grumman order being reduced to 770 examples and the GM contract being canceled outright. In the spring of 1946, a mock aerial combat between the Bearcat and the new Lockheed P-80, on loan to the Navy from the Army Air Forces, proved beyond doubt that the jet aircraft could fly rings around the propeller aircraft. However, in that same year, an unmodified production F8F set a time to climb record of 10,000 feet in 94 seconds for a climb rate of 6,383 feet per minute. The Bearcat held this record for 10 years until it was broken by a jet fighter. In 1948, Grumman introduced a number of improvements to produce the F8F-2. Among the changes were a modified cowling design, taller vertical fin, and the slightly more powerful R2800 engine producing 2,240 horsepower. A total of 365 F8F-2s were produced, including night fighter and reconnaissance versions. Pilots loved the Bearcat for its speed and maneuverability. Its capability for aerobatic performance is illustrated by its selection in 1946 by the Navy's elite Blue Angels to replace the Hellcat. The Blue Angels flew the Bearcat until the team was temporarily disbanded in 1950. Bearcat production ended in 1949 with a total of 1,265 aircraft produced. In the same year, the Navy squadrons began retiring the Bearcats until the last one was withdrawn in 1952. The last piston-engine fighter aircraft built by Grumman would never see combat in World War II or the Korean War, although it was used extensively by the French forces in the French Indochina War in the early 1950s. The F9F Panther and McDonnell F2H Banshee replaced the Bearcat as their performance and other advantages eclipsed piston engine fighters.